Alright, so we're working on this week on the week 9 activities. I want to quickly review what we've done in week 8, which focused on measuring current and voltage. Of course, the simple circuit, voltage supply, switch, resistor, voltage across that resistor, sometimes called the voltage on the load, or L. Last week we practiced measuring current through the loads, and then measuring the voltage applied to the loads, and figuring out the resistance of the load, sometimes through measurement, sometimes through calculation. So the series activities you did last week was 4 series resistors, which of course had a common current passing through all of them, so the current measurement was very similar. But they did have separate voltages. Because the resistors were all the same, Ohm's law helps us figure out that the voltages should have been very nearly the same. Okay, and then also on the parallel circuit, the resistors were again all the same, and the voltage was applied the same to all of them, which of course means also that the current going through each one should be close to the same. But the current coming from the power supply to feed all of them ends up being higher because it needs the current for each one of them. All right, so that's some of the key observations from week 8. Hopefully you can see that in your data and you're sharing that in your PowerPoints. So let's start talking about the cascaded switching circuit we want you to work on for this week. So as in the reading materials and some of the other online materials you've got, the cascaded switching circuit that we're going to use is a transistor-based circuit. It has a primary circuit that activates the transistor when it acts as a switch, and the secondary circuit, which includes the larger power draw loads that we're going to have, so our heater and our solenoid valves. Again, this is all a part of our larger fish tank control system. We're going to use this circuit to control when the heaters come on and when the valves open to add our salt water and deionized water. So, again, our primary circuit consists of the Uno32, which is turned on and off internally by our programming, so it's going to send either a high or a low, so our square wave that shows here indicates that. It's going to drive current through the resistance that is connected to the base of the transistor. And then we have a second resistor here. We'll call it a pull-down resistor. It's one we won't control. It's not part of our design, but it is important. It helps shut off the transistor when the input goes low. So, but your design for this week is going to be selection of RB using Ohm's law. So, and then just to revisit on the secondary side one more time, our secondary power supply happens to be a 12-volt power supply. As the transistor gets switched on, this circuit closes and a second current flows through the heater and also lights up our LEDs to indicate that the power is on. We'll do current and voltage measurements on this circuit to make sure that the power needed by the heater and the solenoids is capable of being met by our power supply, in this case V2, but our plug-in power supply on the table. Alright, so let's move from this schematic to maybe one that's a little simplified relay model. So in the reading materials we discussed how a relay can pull a switch closed with a magnetic field. And so we can always show you one of those, but since we're using the transistor, let's create a little model here. We still have our Uno32 driving the base resistor, and the transistor is modeled as some voltage drop of some device. But when that voltage drop is created, the switch closes. And so you can see that there's two clearly delineated circuits in this type of a simplified model, the primary circuit and the secondary circuit. So this just should help a little bit with understanding, but when it comes to wiring, we'll be going back to the original schematic we had just a second ago. Let's talk a little bit about the primary circuit. Okay, so the primary circuit, again, our emphasis is choosing the base resistor to protect the Uno32. It can only provide a limited amount of energy, and we want to make sure that we don't ask for more energy from the Uno32 than we can. So again, generally speaking, the Uno32's digital outputs is what we'll be using. They provide about 3.3 volts, and we'll call this V1 in this schematic. That drives a current through the base resistor and then across the transistor. Right, this VT we're calling the transistor voltage. So the limit on the Uno32 digital output, we're trying to keep it around 7 milliamps max. And so we want to do Ohm's law so that we can choose a base resistor so that this current is no larger than 7 milliamps. So let's take a look at that. So Ohm's law, of course, is the voltage across the base resistor is equal to the current going through it times the resistance of that base resistor. So the resistance is the piece we don't know. So what do we know? We know that the the voltage across that resistor is equal to the source voltage minus the transistor voltage, this difference between the two. And so we need to determine that. And so if the transistor voltage is given to us as about 0.7 volts, then the base voltage is going to equal to 3.3 minus that, so about 2.6 volts. Now, given that base voltage and our max current, or our preferred current, we can calculate RB, and we'll leave that for you in class. You've done enough Ohm's law calculations to complete this. And so this is the primary circuit, and we'll be getting this set up here in just a second. Alright, so again, you're going to figure out which RB to select. So let's talk about our components that we've got to use today. So here you'll be given this group of supplies, resistors here for selection of the RB and also for the pull-down resistor I mentioned, the LEDs that you'll need for the three circuits, and the transistors that we'll be using. Alright, we've also provided a small battery pack to test the circuit rather than using our Uno32. I'll show you that in a few minutes. And in the box we've got our heater and some extra wires to complete some of the wiring out to the valves and heater assembly. So, pulling out the supplies for just the first circuit, we've got our a transistor. It's called a TIP31A. I'll show you a little bit more about that in a second. I chose a resistor. You'll have to choose specifically. If you choose this one, it may or may not be right. So I suggest that you do that calculation before you choose your base resistor. This is the resistor, the 100,000 ohm resistor that we'll use for the pull-down resistor, and then I chose the red LED for our first circuit. So let's take a little bit closer look at the transistor. So far we've only seen it in the wiring diagram, and here it is in scale. So the transistor we generally call it has the schematic diagram shown here. We call the base this portion, the collector, and then the emitter. And so that's great on the schematic, but what does that mean for our TIP31A component? So if you're looking at the TIP31A, and if you look closely at this, you can see it's got a metal back piece that is usually bolted to a heat sink, and then the component itself is embedded within this material. So I've tried to orient things the same. So if you're looking at it from this direction, you've got pins 1 is the base, pin 2 the collector, and then pin 3 the emitter. And so this is how we'll be doing our wiring here today. You can come back and take a closer look at this in the video if you get confused. I always go back and look at the schematic diagram that's also available on the lessons. Alright, so we'll move from understanding a little bit about the transistor to completing the wiring on the primary circuit. So back to the original schematic, or at least a piece of it here, the primary circuit side. Again, use Ohm's law to select RB, and then complete the circuit on the breadboard. And so we're going, at the first part here, we're going to leave out the Uno32, and I'll show you, we'll come back to it later. But we're going to select RB and grab the R value of 100,000 ohms and assemble them with the circuit. So let's go ahead and do that. I'm going to grab the transistor and plug it in. I'm usually given a space of about 4 or 5 on the left hand side. I'm going to bend it forward a little bit so we can see a little bit better. Looking at the circuit, we need to go from the base, pin 1, which is the left hand pin today, from the base out to a spot where we can plug in the Uno32, and that's using the RB that you're going to calculate. Now I'm just selecting one. In general, you'll have to calculate the actual value. So again, I'm going to plug it in right behind this. It's going into pin 1 on the transistor, and I just took it to an open column here on the breadboard. Okay, now back over here to the schematic. The pull-down resistor is going to go between pin 1, and it comes down and hooks to the ground. And so ground also is connected to pin 3, but we'll take care of this one first. So I'm going to grab the 100,000 ohm resistor, and I'm going to take it from pin 1 also. And so in this column, and I want to take it to ground. And so let me bend that over a little bit so you can see it's connected into the same spot as the base resistor, and then connected to ground on the 12 volt power supply. One thing to point out here, let's go ahead and add one other. I have a few extra wires that you should include. So we want to connect the 12 volt ground to our 3 volts ground coming in. And so I'm jumpering it across, and this side will be used for 12 volts, and this side will be used for 3.3 volts coming off the Uno32. So we want to be careful. We don't want to jumper the 12 volt and the 3 volt together. That won't work. But we do want the grounds to be tied together, and so that's the purpose of this jumper wire right here. Now let's go back to our circuit. So we need to couple pin 3 to ground. So I'm going to grab a short piece of wire here, and pin 3 again, 1 is on the left, 2 is in the middle, and 3 is on the right, and I'm going to connect it also to ground. So again, that's that piece of wiring. And what's left? The next piece is we want to come from the ground out to our terminal block. So I'm going to grab output here. I'm going to take from the ground out to our terminal block. Get this ready for the Uno32 to hook into it, and also want to bring in the positive voltage to the terminal block. And so we're going to come in here on the positive voltage right here, tie that together. Oh, actually, yeah, that's I'm going to use this. I want to use the orange one since it's a digital signal coming in. I want to use an orange one that's a little bit different. Okay, and that's going to come in. So this one needs to come in, but it doesn't come to the terminal block. It's going to come in and connect where resistor B is at. So I'll plug this in, and I'll back up so you can see it a little bit. So again, it comes off the terminal block. This is the signal coming in from the Uno32 that will trigger, and it's connected to the resistor, which then goes into the transistor. So let's take one more look. What we provided on the circuit, we're coming from the terminal block, which is where we're going to attach the Uno32, through the base resistor into the transistor, also into the base of the transistor to ground, and then from pin 3, the emitter of the transistor, to ground. So that circuit is all set up right now. Alright, so let's take a look at the secondary circuit. We'll come back and check them out both later, but let's finish the secondary circuit now. So first thing to do is we want to go ahead and put in our indication LED, and so it's going to go from the positive 12 volts. We're going to go through the LED into pin 2. So on the breadboard, again, here's the LED. The longer leg is the positive leg, so that's the one we want to plug into 12 volts. And we want it to also be connected to pin 2, and so that's the middle one. Okay, and I forgot to unplug these. While you're setting them up, please do it unplugged. So that gets our LED, and it should turn on when it's activated properly. The next step is we need to go and connect the heater. And so again, on the heater, we need to go from the plus 12 volts out through the heater and then back to pin 2. So this is a long one. That's follow along with me here. We're going to come out of the plus 12 volts, and we need to go out toward our fish tank model. And so we're going to go out here, grab my screwdriver, tighten this down. Now to get out to the fish tank model, we're going to need one of our longer cables. And so we'll take this one, slide it under these two terminals, and tighten that down. So again, one of these takes the voltage out, goes through the resistor, and then comes back. So we'll come back here. Let's take this out. We're going to connect it. Today we're going to connect it through a solenoid because you'll be a little more audible. We're going to go ahead and connect this and this. So that shows our voltage coming in, going out to our solenoid, through the resistance of the solenoid, back through our connecting wire to this terminal. So now this is where we need to jumper this back to our pin 2 on the circuit. So we connect it in here, jumper across, and connect it also to pin 2. And it's always better to use a little bit longer wires. I think what I did is I used the wrong one in the wrong place. Let me fix that so I can reach it a little bit better. So wire this one in, and now jumper it over and connect it to pin 2. Alright, I'll restore this, our original primary circuit, jumping in here, providing ground to the breadboard. Now, alright, so back to the secondary circuit again. We went through, out of the 12 volts, through both the LED and the heater into pin 2. Previously we already connected pin 3 to ground, and then we placed the jumper wire between the 3.3 volts power supply and the 12 volt power supply. Let's take one more look at that. Our ground came back through, we came off pin 2, and pin 3 goes to ground. We jumpered that ground over to the 3.3 volt ground, and the secondary circuit is now complete. Alright, so the secondary circuit's prepared. We're going to do one more thing here to kind of test what we've set up. First we want to double check it, so go through and have your partners double check both the primary and the secondary circuits. Don't connect the power yet. And when you're all confident that you've got it, you should probably have it checked by your peer mentor or your instructor before you go ahead with this. You should also, while you're doing that, identify where to include the meters. Because remember, we need to double check that we've limited the current of RB on the primary circuit. Alright, this is specifically for the primary circuit. So how are you going to measure the voltage of RB and the current passing through it? So that's the measurement you'll need to take. So a little practice from last week. Right now, let's assume that I've gone through and I've double checked the circuit. I want to test the circuit using a small AA battery pack. So I'm going to grab this small AA battery pack, and I was careful to put the batteries in according to what they say internally, so that I know that this is the low side and this is the plus 3 volt side. Of course, 1.5 volt batteries will give us about 3 volts, which is similar to the Uno32. So what we're going to do is make a quick touch. Now, I've got this wired up with the valves, so those solenoid valves actually make noise when we're activating it. So I'm going to make contact here with the ground, and then I'm going to touch this. You should see the lamp light up if it's wired correctly, and you should hear the solenoid valve click. Oops. Make a common mistake. Make sure now is the time to turn on your power, because the 12 volt won't activate the relay just yet. So we're going to touch the ground here, and then there's the LED on, and the valve is active. When I pull it free, it drops free. One more time. And the LED is on and working. Alright, so again we're going to test the circuit using this 3 volt power supply made up of 2 AA's inserted correctly in this holder. So we've got ground and 3 volts, and so I'll hold the ground against our ground terminal, and that goes over, and then we touch this here, and so you should see the LED light up and hear the solenoid valve operate. Our LED is not lighting up quite right, so we'll have to check into that, but the valve is certainly operating. Okay, so let's step back from here and review this. So again, we tested the circuit using the small AA's. We checked for the LED operation and the valve. The LEDs seem to operate, but we may have to check something there. We'll help you out in class. If it didn't work right, so let's investigate and repair it as needed. Double check that you got your circuit right. Work with your partners to make that happen. And finally, remember the important part on the primary circuit was to find out what current was flowing through RB. So complete your measurements of the voltage and current on that base resistor, so we can compare them to what we were planning in order to protect the Uno32 as it becomes a part of the circuit. So we'll come back and attach the Uno32 in a minute, but let's move on to the next part of the circuit. So you do want to identify where and how to complete the measurements of the secondary circuit. Remember, we're going to take voltage and current measurements for the heater and the 2 valves, right? And so you're going to, again, create a spreadsheet and complete the measurements necessary for the power calculations. The goal here is to compare the power needs for the heater and the 2 valves to the available power from the secondary power supply. Let's take a quick look at that secondary power supply. So that's this power supply right here. It provides external power to the board, and this is what we use to activate those. So you'll want to make sure and check the characteristics of the power supply. This happens to be a switch mode power supply, and you'll need to review the output voltage and the output current that it's capable of providing. Those are the ones you want to compare to our power needs from the heater, solenoid valve 1 and solenoid valve 2. So take a good look at the label on this so you can make some good comparisons. Now, let's step back 1 second and just review one more time. Set this aside. So the only thing we haven't done is activate the valve using the Uno32. So I'm going to add, I've used orange colors here for this particular one. I'm going to connect 2 wires here so we can reach out to the Uno32. I've got the signal coming from the digital output that we're going to program, and I have ground coming in. And so I've put the program that was provided for you for basic operation into this Uno32. And again, the wiring is, the program you're provided has the heater on digital output pin 3, and so following the labeling down the side here, pin 3 is actually the 4th one up on this side. And, oops, plug that into ground. Careful about that. Ground, where we've been using it last week, and then digital input pin 3 is the 4th one up. And so I'm using colored ones for the digital controls and black for ground. Now this program is set up to run this digital output 3 for 1 second every time we push this button. So it takes about 3 or 4 seconds for it to load, but it should activate the circuit here in just a second. So I'll press this. And there's the solenoid being activated. I didn't see the LED come on, so we will have to investigate what's going on there. We might have to put a resistor in there. So again, you'll need to program the Uno32. The base program that we provided tells you how to send the outputs low. You'll have to modify them to run them high and low for a certain amount of time so you can complete your measurements. Again, the tough part about this week is wiring this up and then taking the measurements necessary to find out both the current traveling through the base resistor and then the power going out to the different loads. So that brings us to the end of week 9. Make sure and get those measurements done during this week, and you should be all set to respond to questions and complete your PowerPoint.